We're going to be switching gears a little bit in this lesson and talking about polynomials. And the one thing we really need to cover is polynomial division. But I want to review some things that are taught in Math 050 and that maybe you've seen in the past. That'll help us get through this section as well as the next couple of sections. So we're going to review multiplying binomials, which is basically just a polynomial with two terms. And then we're going to talk a little bit about factoring. We're going to come back to that discussion in a couple weeks. And we're really going to focus on dividing polynomials. So let's start by reviewing multiplying binomials, things that have two terms. And you might have learned the acronym FOIL in the past. It really is just an acronym to help you remember that you have to distribute every possible pair of terms. The letters stand for first, outer, inner, and last. So for example, in this first problem, first two terms would be x times x, that's x squared. The outer is the x and the 4, so plus 4x. My inner is the minus 3x. And then last would be minus 3 times 4, which is minus 12. And then we can combine like terms. We're left with x squared plus x minus 12. So that's what I meant by multiplying binomials, really just using this FOIL process. So then in part B, it's the exact same thing. First would be y times y, or y squared. The outer is the 2 times y. Inner is 7 times y. And last, let's see, 2 times 7 is 14. When I combine like terms, I get y squared. 2 and 7 is 9, so plus 9y plus 14. Finally, one more example, this a plus 5 squared. This is the same kind of problem. This actually means we're taking a plus 5 times a plus 5. This is another FOIL problem. So let's see, first would be a squared, outer is 5a, inner is 5a, and last is 25. And when I combine like terms, I get a squared plus 10a plus 25. Notice it doesn't work to just square the a and the 5. You do actually have to FOIL this out, otherwise you'll be missing that middle term. Now I wanted to point out one other thing that's happening here is notice that in example A, we were multiplying x minus 3 by x plus 4. We had a minus 3 and a plus 4. The thing that I want you to notice is the middle term is a 1x, and the last term is a minus 12. Notice that minus 3 plus 4 is 1. That's the middle term. Minus 3 times 4 is minus 12, the last term. And this pattern holds with my other examples. In example B, I had a y plus 7 and a y plus 2. And let's see, 2 plus 7 gives us the 9, which was in the middle, and 2 times 7 gives us the 14, which was the last term. And then finally in part C, we have a 5 and a 5. And notice 5 plus 5 gives us the middle, 5 times 5 gives us the 25. Now factoring is the opposite of multiplying. It's breaking things down in the opposite direction. And so if you think back to that pattern from example 1, we saw that the middle term came from the sum of those two numbers, and the last term came from the product, or when you multiply the two numbers in the parentheses. So if I want to factor something of the form x squared and then there's an x term and a constant, basically the idea is I know that this is going to be an x and an x. That'll give me the x squared. And then I have to find two numbers that have a sum of the middle and a product of the last. So in this case, I want the sum to be -1, and I want the product to be -2. And so it's a good idea to start with that product and think about, well, what are all the ways you can get a product of -2? Well, really, it could just be 1 and -2, or -1 and +2. Those are the only possibilities. And then you just check, well, which of these add up to -1? That would be the 1 and the -2. All right, so that means in my parentheses, I'm going to have a +1 and a -2. And if I were to FOIL this out, I would get back to where I started. So multiplying or using FOIL is expanding. And then when we factor, we're going in the opposite direction. We're trying to break it back down into a product. So two more examples. In example B, we want to find two numbers that have a sum of the middle number, so a sum of -7, and a product of the last number, product of 10. And so I'm going to start by just making a list of my possibilities. And I always start with that product. So product of 10 could be 1 and 10, or 2 and 5. And which one adds up to 7? Well, the 2 and the 5 would give me a 7. But if I want it to be a -7, well, I'd have to make it a -2 and a -5. That still gives me the positive product. And so that means my final answer would be x minus 2, x minus 5. All right, last one more of these. I want to find, oh, and you know what? I just noticed I have a little mistake here. This should be a y in the middle. The variables need to match. If they don't match, then we can't factor it. And so let's just change that to a y. So now we can use the same process. I need a sum of the middle, which is 4. And I need a product of the last, which is -21. So I start by thinking about how can I get a product of 21? Well, it could be 1 and 21 or 3 and 7. And because it's a negative, one of these numbers has to be negative. We have a positive sum. So I'm going to make the smaller number negative. And then let's see. Oh, yeah, 7 and -3. That does add up. That gives me a sum of 4. And so my answer is going to be x minus 3, x plus 7. Now, as I said before, we'll come back to this idea of factoring a little bit later on. We'll talk about all different kinds of factoring. But for now, I want you to just focus on these trinomials. That's what we call something with 3 terms. But I want you to focus on these types of problems where you're just looking for the product and the sum. And again, this is going to come up in the next lesson, which is why I'm kind of running through it right now. So to multiply polynomials, we can use that FOIL acronym. We can distribute, that's multiplying. If you want to do the opposite of multiplying, technically we are dividing. And one way of thinking about that is factoring. Another way of thinking about that would be using division. And specifically, I'm thinking of long division. We can actually use long division with polynomials, with things with x's. But before I show you that, I'm guessing it's been a very long time since you've had to do long division by hand with numbers. And so let's just run through that really quickly. The process is, if I want to take 723 and divide it by 6, well, I start by just looking at the 7. 6 goes into 7 one time, so I divided. Then I multiply. I have to figure out what the remainder is. So 1 times 6 is 6. And then we subtract, remainder of 1. And then I bring down the next number and repeat the process. 6 goes into 12 2 times. 2 times 6 is 12. Remainder of 0. Bring down the next. 6 goes into 3 0 times. And so then this 3 is actually my remainder. And so I can say my answer is 120 with a remainder of 3. Or we could write that as 120 plus 3 over 6. That's the remainder over the divisor. Or I guess in this case, it'd be 120½ 3 over 6 is a half. So basically, we're going to use this exact same process with polynomials. We divide, and then to find the remainder, we have to multiply and subtract. We bring down the next term, and then repeat the process. So let's take a look at an example. And this is the part of the problem, or this lesson, I really want us to focus on today. So we're going to divide 3x squared minus 5x plus 6 by x plus 2. So I'm going to start by just putting this into a long division problem. And then I'm going to try to go through the same process as before. I start by dividing, and I look at first two terms only. So I need to figure out, I'll do this over to the side, what is 3x squared divided by 1x? That's 3x. So then I'm going to write down on the top 3x. Now I have to find the remainder. Erase this. All right, so to find the remainder, we're going to multiply. So I'm going to take 3x, and I'm going to multiply that by x plus 2. That's 3x squared plus 6x. So 3x squared plus 6x. So we divide, we multiply, and now we're going to subtract. I'm going to subtract both of the terms to see what my remainder is. The 3x squared goes away. It should go away. And then minus 5x minus 6x, that's minus 11x. So that's my remainder. And then I bring down the next term and repeat the process. Once again, to start to do the division, we look at the first terms only. So we have to figure out what is negative 11x divided by x. That's negative 11. I'm going to write that down on the top. And then I'm going to go through the exact same process. I'm going to multiply. Let's see. So we're going to take our minus 11, multiply that by x plus 2, and then we can subtract to find the remainder. So that's minus 11x minus 22. And then I have to make sure to subtract both terms. Now, when you subtract a negative, they become positives. So minus the minus, both of those become pluses. The 11x's go away. 6 plus 22 is 28. There's nothing else to bring down, and so the 28 is the remainder. The 3x minus 11, you could say that's your quotient, and 28 is your remainder. In some problems, you might be asked, what is the quotient, what is the remainder? And you can just type them in, just like we found. But another way of writing your answer is you can say that your answer is the quotient, 3x minus 11, and then you take the remainder and you put that over the divisor, the thing you divided by. And so this is equivalent to the division problem we started with. It's kind of like we took a fraction and wrote it as a mixed number. So you always put the remainder over the divisor. And that's our final answer. Let's do one more example. So I'm going to write this as a long division problem. I'm going to copy down the first polynomial, 6x to the third. But notice this polynomial starts with an x to the third, but there's no x squared term. And so I actually have to put in a plus 0x squared. You want to put in a placeholder for any term that's missing. In other words, you need to have a spot for every single power of x. There was no x squared, so we put in a 0x squared. If there was no x, I would put in a 0x. All right, and then we're dividing by x minus 3. So to get started, we divide. We look at the first terms only. So 6x to the third divided by x, that's 6x squared. I'm going to write that down on top. And then next thing I have to do is multiply. So what is 6x squared times x minus 3? That's 6x to the third minus 18x squared. And so I'll jot that down over here. 6x to the third minus 18x squared. And then we're going to subtract both terms. So this will become a minus. Minus a minus becomes a plus. So you can think of the subtracting as also changing the signs and adding. We're left with then an 8x squared. And then, or I'm sorry, I said that wrong. I think I wrote it down right though. 18x squared. And then I bring down the next term, which is a 4x. All right, so now we repeat the process. First terms only. So what is 18x squared divided by x? That's 18x. So I'm going to put down plus 18x. And then I have to find the remainder, so I have to multiply. I'm going to take the 18x and multiply that by x minus 3. That's 18x squared minus 54x. So let's jot that down. We've got 18x squared minus 54x. And then we're trying to find the remainder, so we're going to subtract both terms. Minus, and this one becomes a plus. So basically, change the signs and add. The x squareds go away. 54 plus 4 is 58x. I've got one more term to bring down. So that means I've got one more division problem to do. I'm going to take 58x, divide that by x. And if you can do some of this in your head, that's great. You don't have to show all the work that I'm writing down. I'm just trying to be complete for your notes. So 58x divided by x is 58. All right, find the remainder. So we have to multiply. What is 58 times x minus 3? That would be 58x minus 174. So 58x minus 174. And then almost done, we're going to subtract to find that remainder. So minus, that one becomes a plus. The x's go away. Minus 2 plus 174 is 172. There's no more terms to bring down, so I'm done. The 172 is my remainder. The thing on the top, this is my quotient. Again, the 172 is my remainder. And if I want to write that final answer as one expression, I would write the quotient, 6x squared plus 18x plus 58. And then you can do plus the remainder over the divisor. And that's my final answer. All right, as always, when I do some review material, I know that it's too fast for some people, probably too slow for others. So please let me know if something in the review stuff didn't make sense. In addition, I know that this long division is kind of confusing at first. I promise the more you do, it'll start to click and make a little bit more sense. It's definitely a topic that takes a lot of practice. But you can always use the tutors in the math lab or the college prep zone, and you're more than welcome to come to office hours.